with these journals. Medical Physics, which publishes original high-impact medical physics papers. And JACMP, which publishes applied clinical papers. So I really tried to highlight that fact and the fact that we really publish things that we want to help clinical medical physicists with in their daily tasks. A couple of key points about the JACMP is that it is and always has been an open access journal since 2000, the year 2000 when it started. We're celebrating our 25th issue this year. And JACMP reviews are double masked, or some people say double blinded. That is, the authors don't know the reviewers and the reviewers don't know the authors. And we think there's a lot of value in that. Just quick history. None of you in this presentation will remember this organization, the American College of Medical Physics, but it was founded in 1983 by the AAPM. And in order to have an organization that looked after professional and educational issues, as AAPM really was largely a scientific organization at that time. So ACMP started in 1983. And 15 years after the creation of ACMP said, well, there's a gap in medical physics publishing, and that is content for clinical medical physicists. So there was a committee that was formed. The committee said, we want this journal to be a little different. It should be electronic only, and there should be no cost to authors to publish and no cost to readers to access that. And in starting this journey, starting the journal, there would also be no financial support from AAPM or members, and we weren't allowed to compete with medical physics. So this was a self-sustaining journal, free to publish and free to access. The first issue came out in the year 2000. For the first 11 years, we published 4 issues a year, built up to 6 issues a year, and now we do just exactly what medical physics does. That is, we publish 12 issues a year. A new issue comes out each month. And typically there's something like 30 articles. Yeah, 30 articles each month or so. Early on, we realized it was expensive to publish. So we switched from an expensive publisher, AIP, American Institute of Physics, which was publishing MedPhys at that time as well, to Multimed. And because continuing to publish for free was one of our key goals. So we could publish at a lower cost, still have no APC, that's an article publishing charge. And we had some small banner ads on the website that would help support that. We went through several editors. Some of you may know Peter Allman. He was the first editor. Michael Mills is the current editor, and I think Michael will probably be stepping down in a year or two. The reason that most of you young people on the call haven't heard of the ACMP is because it went away in the year 2011. It was dissolved into AAPM, and at that time, AAPM took ownership of the JACMP, and AAPM decided, you can see my frown face over here, that it couldn't be free anymore, that we had to charge $500 for authors to publish in JACMP. And I'll talk a little bit more about that charge. And you can just see some of our recent growth. So now we've kind of plateaued at around 750 submitted articles a year, around 350 published articles per year. But you can see just this huge growth in the number of users and the number of downloads. And I have a slide in a minute or two, which really shows the value of open access articles in terms of their global reach and global downloads. Here are our downloads by country over the last few years. And you can see the large majority are the United States and China. Not surprisingly, that's where we get most of our submissions as well. And I think it's really good that I'm on this presentation today, because here's Canada down at running from 7 or 8. So you all should be more aware of the JACMP, and you should go to those great clinically applied articles and download those, please. So what all do we publish? We publish original clinically oriented articles. So there should be some novelty in those. But these are not hardcore basic science articles. We publish original technical notes, but we also publish a lot of other things. I'll show you some examples. Education and professional articles, education and clinical case reports. We do publish a large number of AAPM documents. We publish editorials and letters and book reviews, etc. And George Starkshaw was the third editor-in-chief, and I pulled this out because I was looking at some old content recently. And I really like this quote that George made in 2008. The real measure of impact of a paper in JACMP is the number of times the information is used by a practitioner of medical physics to improve the quality of their practice. So that's, in a nutshell, our primary goal. And, you know, not just in the developed world, this is a global journal, and it's available for free throughout the world. So we do see a lot of growth in global downloads and readership. Just a couple of examples of some of the things that you might not even think about publishing. Design and implementation of an electronic whiteboard. Here from this group, you may recognize some of the names: linear accelerator maintenance and cost analysis. So, you know, whatever you might think about, you can think about, can I publish this in the JACMP? Again, doesn't have to be cutting edge science or cutting edge clinical applications. Here's some of our education articles. Oops, sorry. Equity, diversity, inclusion in physics residency journal clubs, as an example. So again, not just clinically applied papers, but education, case reports, professional issues, etc. You know, I've kind of said this already, but why would we publish in open access? Why would you publish in open access? And that's because your paper will get the most attention it possibly can get in an open access journal. So you can maximize the dissemination, it's economically efficient, and you can maximize your social impact. So on average, this comes from our publisher. By the way, the publisher of MedPhys and JCMP is Wiley. 3.5 more views, 1.5 times more citations, 4 times greater altmetric score. So if these things matter to you in your careers as metrics for promotion, or they just matter to you in disseminating as widely as possible, open access is a very good way to do that. Open access comes with a little bit of a cost, so let's see what that is. First, there are several flavors of open access. The JACMP is called Gold Open Access. That is, you submit your paper, it gets accepted, and it's going to be published, and then somebody, we'll talk about who, pays an article processing charge. Currently for JACMP, that's $760. And it's immediately online, and it's immediately available to everyone. As opposed to the subscription-based model, where you submit, it gets accepted, you don't pay a cent yourself, but somebody is still paying for this, and we'll talk about who. And then it's online, but of course it's behind a paywall. So if you publish in MedPhys and you're an AAPM member, you have access to it. If you publish in MedPhys and your library subscribes to MedPhys, you have access to it. But if you're not in those kind of fortunate categories, you don't have access to those subscription-based manuscripts behind paywalls. And then there are hybrid journals. So you might submit to a subscription-based journal, and they may say, well, you know, if you want to pay an APC, we can put it online for you. Depending on the APC, we'll talk about those in a little bit. You may decide to do that. And there's this there are several different kind of intermediate categories, but green open access is one, and you may have a journal which says it's okay to put your paper in a repository. So many of you are familiar with Archive or Research Square, those kinds of preprint servers. So it's okay to do that at least until it gets published by the journal. So here are the APM journals. As I said, MedPhys is open access. It costs $760. We'll talk about who pays that. There is a full waiver from developing countries and a partial waiver from other countries. And if you are a student member of AAPM, you get a 50% discount. MedPhys is a hybrid journal. That is, it's subscription, but if you want your article available open access, then you pay $3,200 to do that. And this is just screen capture from the web pages of both of those. But what you'll see is on the MedPhys side, you see this open access. So here the authors decided to pay the APC. So everybody has access to that. Whereas on the other two manuscripts, those would be behind a firewall. And on JACMP, you'll see the open access next to everything because all articles are open access. You all in pursuing your academic career are aware of other journals in the medical physics space. So PMB, like MedPhys, is a hybrid journal. If you want to pay for open access, it's $3,100. Physica Medica is a hybrid journal. Their APC is $2,400. And FIRO is completely open access, and it's $1,500 to publish there. So we think that even though JACMP articles aren't free to publish anymore, they're still pretty reasonable, and it's a good bargain at $760. What about copyright? So as an author, you're given what's called a Creative Commons copyright. That allows you, depending on which category of Creative Commons license you publish under, that allows you to share your article as you would like. And it also allows other people to redistribute your work and so on. The AAPM journals, both of them, if you publish open access, they're published under the most liberal Creative Commons license, which is CC BY, and it allows all of these uses as long as you are attributed. So it doesn't mean somebody can take your name off and submit it for publication. That would be plagiarism anyway. Doesn't mean somebody can include parts of your article without citing you. It just means that you can distribute it and others can distribute it, and there's no fear of any kind of retaliation if you're distributing your article. Okay, so who pays? Well, for subscription paywalled articles, it's typically a subscription that your library may have, if you're fortunate enough to work at an institution that has a library or some other kind of institution, or a corporation that subscribes. So universities, all of these organizations subscribe. They may do so as part of a larger consortia, but they all subscribe. And of course, if you're AAPM members, you have access to both journals as part of your membership. And who pays the APCs? Well, it's not institutions for the most part, although it may come through an institution. Fundamentally, when you get the acceptance from JACMP or any other open access journal, you'll get a bill. Thanks, we're ready to go. Please send us $760. So the author will get that bill for the most part. You may go back to your advisor or your department chair or somebody at your institution and say, can you pay it for me? You may be fortunate enough to have a grant that will pay these kind of costs. But ultimately, it's authors and consortia of institutions that are going to end up paying the APCs. So you may view this as a downside. Well, I got it published, but now I owe $760. But as I'm going to show you, there's lots of different mechanisms to explore to get these APCs paid, so you don't have to do it yourself on a student budget. Before I moved to Seattle, I was in San Francisco at the University of California, sitting at my desk doing my work, and something that comes across the computer, and it says, the publisher Elsevier and the University of California have come to an impasse, and UC is not going to subscribe to Elsevier publications anymore. They're too expensive. And I thought to myself, well, okay, who publishes in Elsevier? Oh, the Red Journal does. And then I started thinking about it. A lot of journals publish in Elsevier. So at that time, if you weren't an Astro member, you would have lost access to the Red Journal. So that's, and you know, I think that's probably a drop in the bucket to some other disciplines who would have lost access to their journals. But the point is, UC decided it was too expensive, and so we're just not going to resubscribe. So that went on for a year and a half. And then in April 2021, a year and a half later, they came to an agreement. We'll call it a transformative agreement or a transformational agreement, because I'm going to talk a little bit about those. And they came to an agreement that enabled UC authors, notably, to publish their research open access in Elsevier journals. That's what UC authors really wanted. It gets their material disseminated the most widely. And how was the cost covered? Well, there was some kind of payment by UC, but not like it was before, so a reduced subscription. And then UC also said, well, we'll allocate funds to our faculty, students, et cetera, to cover the cost of the APC with Elsevier journals. So I underlined that and put that in bold. So this is what the agreement said, but there was not like a pot of cash that came down from University of California headquarters and said, here, everybody, you have all this APC money. They really preferred that, that the individual labs, the individual departments, the individual institutions would continue to pay those APCs. So they passed the buck a little bit in that regard. So that's an example of a transformational agreement. A contract between academic institutions, or a bunch of them, that shifts the business model from this expensive subscription-based to open access. It may be a zero-sum kind of a thing. So it may be that the subscriptions go down, but now we have APCs to pay. So it maybe is not exactly saving money, but there's the value in having open access. Most of you, many of you may not have heard of transformational agreements, and I bet you don't know who has them, but there are 52 agreements in the US and Canada covering, this is with Wiley only, covering over 500 institutions. So, and in fact, if you see on the right-hand side of the screen, 64% of Wiley publications are covered by a transformational agreement in Canada. So it very well may be that you or your colleagues in botany or geology or chemistry may be covered by a transformational agreement that you're not even aware of. So it pays to do a little looking through that. I'll give you a couple more examples of transformational agreements. And sadly, I think none of these three examples apply. Well, maybe the last one applies to Canada, but here's some examples of big ones. So the German government, or a consortium of government and German institutions, decided, like the University of California, they were paying too much, and they formulated this project deal to negotiate these agreements with the publishers. And Project Deal has agreements in place with three of the largest publishers, Wiley, Springer Nature, and Elsevier. And at this moment, if you are an author affiliated with one of these institutions in Germany, you will pay no cost whatsoever. They are paid for by the consortia. That may change in the future, but there's no cost whatsoever for any open access articles in any of these, with any of these publishers for their journals. More recently, I guess maybe then the Europeans said, hey, if Germany can do it, we can do it. So a coalition of European institutions and a few others formulated Plan S. And Plan S works almost exactly the same way as Project Deal. That is, scholarly publications will be subsidized by Plan S and must be published in open access journals. So these two deals may not impact you directly as authors, but they definitely impact us at JCMP as publishers and reviewers. Because this means if something comes from Germany to JACMP, it's covered by Project Deal, and those authors to publish in JACMP don't pay the $760. Similarly, if it comes from a Plan S institution, they don't pay that APC. So it's a little bit more for us to manage, but we overall are very supportive of these kinds of efforts. And then finally, most recently, although the US government takes a long time to get anything done, they started talking about this in 2008. And finally in 2022, they said, yep, that's going to happen here as well in the US. By 2025, if your work is supported by the US government, in this case NIH, it must be published open access. And so that impacts medical physics and JACMP significantly. And we're all kind of thinking about what that impact is going to be and who is going to pay those APCs, because we're not giving them away for free, but it will undoubtedly be some sort of government supplement. And I picked on one of my good friends from UCSF, and you can just see that that's already in place, although it's not a mandate. So if you go to PubMed and you do a search, you'll find here's the article that's behind the paywall, but because this article was supported by NIH research, there's a free text at PMC. You can see that again down here, New England Journal of Medicine. That would be behind the paywall, but it was NIH supported. So there's a version that's online for free. So under transformational agreements, kind of shifts things a little bit. So, you still may get a bill from the journal for $760. You may not get a bill because the journal knows this is coming from Germany. This is coming, your work was NIH supported. This is coming from Europe. And if you don't fall under any of those transformational agreements, then hopefully there's some cost sharing involved, again, as I mentioned before, from your universities, from your departments, from your PIs, from their grants. So it's not that, I guess the point I want to make is the APCs haven't gone away, but the source of the funding for the APCs is being shifted as more open access is being required. Okay, just a couple more minutes. Just switching gears. Article citations, I think you're all familiar with that. You can go on our websites. You can see that this paper has been cited 42 times since July 2020. This paper in JACMP has been cited 102 times. That's the traditional method of assessing the impact of an article. That is, how many times do other articles reference your article? And you can go to any of these websites and others, Scopus or Google Scholar, and you can look up an author and see what their citation index is. You can look up a paper and see how many times it's been cited, et cetera. But that's a traditional method of assessing article impact. And at many academic institutions, it's also the traditional method metric for determining whether or not you may get promoted, at least one of several. So we're starting to move away from those kind of metrics as well. And I'll show you an initiative in just a second. Because there's so much more now in an online world than just citations. And we call those alternative metrics or alt metrics, although alt metrics is actually a trademarked brand. But what if your article gets mentioned 200 times on Twitter or X, or in other platforms? How do we capture that? So there are the several companies now, nonprofit companies, that do track that. So here's an alt metric. This article, wherever it came from, had 2,900 mentions, and you can see where they were, 2,200 tweets, Facebook, Google Plus, etc. And another competing company to alt metrics is called PlumX, but they do the same thing. And so again, you can see here on either the AAPM journals, you can come down here and you can see the little alt metric symbol, which is what we use to track those things. You can click on it. You can say, oh, these have gotten a lot of attention recently, including this one, which has 45, has a score of 45. You can go down and see where that was. Oh, it was mentioned 33 times on X, and similarly. Yeah, so maybe I'll just go to the next slide. So in terms of these alternative metrics, alt metrics, there are a number of large initiatives to say to academic publishing, we need to get rid of impact factors and citation indices, and we need to be more inclusive in terms of what's capturing the attention of these articles. And the key initiative was called DORA. This started over 10 years ago, but DORA has really 3 points it tries to make. That we need to eliminate journal-based metrics, like journal impact factors, for individual appointments and promotions, because in this day and age, that doesn't capture things adequately. And we need to assess the research on its own merits rather than the basis of the journal in which it's published. I can't tell you how many times I've heard the comments, either in reviewing a grant, well, this grant isn't so good, but it comes from a good lab, so let's fund it. You know, the similar thing is publishing. It's like, well, that paper is not so good, but it's in Nature, so it must be pretty good. So it should be based on its own merit and not whether you publish in Nature or Science or JAMA. And then these things then help us to capitalize on the opportunities provided by open access and online publication. So DORA has this many signatories so far. Wiley, the publisher of MedPhys, and JACMP is a signatory to DORA. So Wiley has said, yeah, we agree with this and we will work collaboratively to help to make this. And then last, changing gears, hopefully I haven't taken too much time, but the last point I want to make is, what about AI? So ChatGPT 3, you may remember, was released on November 30th, 2022. It took the world by storm, including the publishing world. So we are wrestling with, how do we incorporate generative AI into publishing if we do decide to do so? So there's so many models that are out there, and because we have an open access journal, part of what that means is those open access articles are all available to these AI models. So for better or worse, our work in an open access publication becomes a very small part of these models. This is a double-edged sword. And this comes from Wiley. I'm just using quotes from Wiley. So AI can assist in the writing process, and we encourage you to use AI to assist in the writing process, especially if English isn't somebody's first language. You can run this through a large language model, and it can make it significantly better. So we don't discourage that. We do encourage it, but there's a big caveat on that, which I'll mention in a moment. But alternately, as some of you may have even played with, the first thing I did was I wrote an AAPM abstract. I got ChatGPT to write me an AAPM abstract, which it did really nicely. You can use these large language models to generate content, both written content and fake images. And so that's not right, and that's not what publishers are going to allow. This is some guidance from JAMA. It's probably the best guidance that's out there. And it says non-human models don't qualify for authorship. Believe it or not, some papers have been submitted and it puts ChatGPT as an author. So that's not appropriate. And if you use these tools, like I said before, we don't discourage their use. You must take responsibility for the integrity of that. So it might give you incorrect references, for example. That's your responsibility. And you need to acknowledge it. So the biggest requirement in the AAPM journals is you must acknowledge if and how you've used large language models. This comes from the AAPM journal's website. The use of AI in any manuscript must be declared in the methods section following the Committee on Publication Ethics. And you can look that up in your spare time. Both journals do use this software to check for, typically we use it to check for plagiarism. And going forward, it'll also be used to check for whether or not large language models were used in preparing a manuscript. These things are evolving rapidly. Here's just another, some other policies by other journals, Science, PLOS1, etc., on whether or not you can use them. At the moment, detecting it is problematic, but our detection algorithms are getting better. And I will just finish here by saying professional organizations like AAPM have some ultimate responsibilities. AAPM supports both journals, but AAPM as an organization and AAPM as individuals, let's say the board of directors, should have a hands-off approach to what's published in the journal. So editors-in-chief should have full editorial independence, which we do. So you never should feel like, well, I'm not an AAPM member, and am I going to get dinged slightly on my submission? Or if I say something critical of the AAPM, is that going to get me a rejection? The editors have complete editorial independence, and that's a fundamental premise of academic publishing. And I will stop there. Believe it or not, where I'm sitting right now is sort of from this view, but this is my view looking past the Space Needle in Seattle, and then to the right, if you look real closely at the Space Needle, you can see Vancouver way over that hillside. Thanks very much.
Okay, thank you so much, Tim. We're going to move on to our second speaker now, who is Dr. Magdalena Bazalova-Carter. She is an associate professor and Canada Research Chair in Medical Physics at the University of Victoria. She's authored over 100 peer-reviewed publications, 4 book chapters, and served as the deputy editor of Medical Physics. She received the John S. Laughlin Young Scientist Award from the American Association of Physicists in Medicine in 2001 and 2023. She was inducted into the College of New Scholars, Artists, and Scientists of the Royal Society of Canada. So, Magdalena, you can take it away.
Now I'm unmuted too, right? And you can see my screen. All right, perfect. Thank you very much. And thanks, Daniel, for the introduction, and Jade and Daniel for the invitation to present today. seems like there will be no overlap with Tim's talk. So thank you, Tim, for setting up the stage. And I would like to encourage everybody to get your phones out, because we will have a few polls throughout this presentation. So hopefully it'll be a little somewhat engaging, and some of you will be responding to the polls. All right, so why am I giving this presentation? That is a very good question. I'm really happy again that I was invited, but I was also on the board of Associate Editors of Medical Physics for about 10 years. As Daniel mentioned, I was a deputy editor of Medical Physics for 3 years for one term, and I stepped down. And I published over 100 papers, almost 200, not almost 200 like Tim did, with about 3,000 citations. And this is the list of our latest citations from my group. But don't get me wrong, you should all know that I got many papers that were also rejected. And that's also one of the reasons why I'm giving this talk, because I know what it takes to get a paper rejected and perhaps resubmit it again, despite of getting some papers rejected and again, eventually published, but not all of them either. It seems like citations are going up still, which is great, and I'm very grateful for my group that actually is publishing. It's not me, but I will be lecturing you on how to publish, even though I don't do that anymore. I don't write papers. All right, so I'm gonna see what I can do here, sorry, with my view. So why should you be writing a paper to start with? There's a few reasons. I would like you to share your research with the world. That's very important. If you do something at home, nobody, or even at the university, and you don't publish it, nobody will know about it, and you will not advance science. But that's what we want to do. And this is my ChatGPT sentence, Tim, for you. We want to advance the welfare of humankind through scientific innovation. And that can be on cancer diagnosis, if you're doing imaging, treatment, radiation protection, or any other topics that you might be currently working on, and hopefully you are working on or will be. You also would like to be able to integrate your research into the existing body of knowledge, and that's very much done in your introduction section. And that's perhaps something that you don't do before you start or embark on your research, and that is very important, because the last thing you want to do is, when you write your paper, realize that after you do your literature research, that somebody has done exactly the same thing and came up to the same conclusions, and that's going to be something that might be very difficult to publish, but I said might be for a reason. You also want to get feedback from the scientific community, and that can be in the form of the reviewers or referees as you are going through this submission process or the review process, but also from readers later, right? It's possible that somebody will email you later on and tell you, oh, this is a wonderful paper, thank you for doing this. Would you like to collaborate? Other people might be like, what the hell did you publish? Why is it so bad? And you made so many mistakes in your work. Hopefully that's not going to happen, but this is a form of feedback as well, and could happen. Of course, it'll get you closer to graduation. Usually, I'm a supervisor. I don't want to say require, but highly recommend students have a certain number of publications before they can defend their theses. And if you get your research published, you're one step closer to graduation. But of course, that also results in making your future job prospects much more brighter. All right, so it seems like we're gearing up for the first Slido, and let's see if this works. Okay, so if you scan this QR code, everybody has done this at a conference or somewhere. And the question is, have you published or submitted at least a scientific paper to a peer-reviewed journal? The possibilities are yes as a first author, yes as a co-author. Unfortunately, you can only choose one, and no or not sure. I'm gonna wait a little bit. I can probably estimate as to how many people have responded based on the percentages. I did put a option for not sure, because I remember when I started graduate school, I actually wasn't sure if the paper that I published was peer-reviewed. The journal was shady, that it wasn't really clear if this went through a peer review or not, but I still listed as one of my very first publication. Okay, so it's nice to see that actually quite a few of you have not published, so hopefully this will be useful for everybody. And it's nice to see that about a quarter actually published or now 1/3 published a paper as a first author. So you have gone through the process or submitted a paper as a first author. So hopefully it'll be useful for everybody. And I think Halle will have a presentation on maybe also how to write a paper, how to publish. So you should also know that whatever advice I will be giving you might be different or very different from somebody else would give you. So hopefully there'll be some overlap with Hallie, but hopefully she also has something new to give you. Okay, perfect. So when should you start writing a paper? When you have something interesting to share with the scientific community that will be useful to others, and of course, ideally, very useful to others. Very often in medical physics, I think we tend to do that. We look at a very small improvement, and I like to say, now the accuracy of Monte Carlo dose calculations is not 1.2% now, it's 1%. So, that's, sort of incremental improvement. So ideally, this is something that's earth-shattering, but often it's not. If you have something that's nice, you should start writing. Typically, that happens when you're a student, when you have completed a project or a sub-project, and you do have a reasonably complete story to tell. Right? You do want to have a story in your paper that says, this is what we looked at. There was a gap in literature or in the scientific knowledge, and we are filling that up with this particular research. I'm saying reasonably complete story. Okay, because there's always more that can be done, right? There's always more things that you can do, always, always, always. So you have to at some point put your foot down and say, okay, this is it, I'm publishing this. Referees might ask you for more, they might be perfectly content with what you have done. You should probably be showing novelty, but that's not the case for all the journals. So I know with the new editor-in-chief, well, new, maybe not so new, with John Boone as the editor-in-chief of Medical Physics, he's actually not necessarily seeking for novelty in scientific publication. So it can be a research article and still can be published if you can replicate other people's research. Now, in my experience, this is the opinion of the editor-in-chief. This might not be the opinion of the reviewers that eventually kind of decide on the faith of your paper. So just keep that in mind. As I said, there's always more to be done. So do remember that perfect is the enemy of done. There's a bunch of sayings how these could go, but it doesn't have to be perfect. As a matter of fact, it really shouldn't be perfect, right? You need to give the reviewers something to do as well. So make sure that you don't sit on a paper for years and polish every single word. I had students who did it. They were wonderful. But you're also on a timeline, right? You might have your own funding, your supervisor might have funding, so you should be at some point finishing up your research. But of course, it has to be, what you submit has to be of good quality. Okay, so how to select the appropriate journal? Is it earth-shattering research? Sadly, in our area, not too often that's the case. Submit to Nature or Science, which are, I know we don't talk about impact factors, but they are highly respected journals in the scientific community for any field, right? Again, that probably doesn't happen. So if it's not the case, definitely look at the standard journals for medical physics, for physics. So it'd be medical physics that Tim talked about already, PMB, Physics in Medicine Biology, Physica Medica, EPSM journals. There's a number of physics-related journals. If it's clinically relevant work, I had to say, JFCMP would be another good journal. The International Journal of Radiation Oncology, Biology, Physics, also known as the Red Journal, Radiotherapy and Oncology are a very clinically oriented journal, and this Radiotherapy and Oncology is also called the Green Journal because we cannot remember all these abbreviations. We just call the journals by the color of their covers. Easy. If it's biology, then the Red Journal, also the Journal of Radiation Research Society would also be good venues for your research. If you're doing an imaging, SPI, Journal of Medical Imaging is a good journal. IEEE, I see it's IEE in my slides, but it should be IEEE TMI, which is the transactions on medical imaging, or if it's very clinically oriented imaging research, then radiology would be a good venue. And very often, you can basically look at the citations of your work and then look at, what's the most cited journal, and that probably would be a good home for your paper. In the same way, if you're submitting your paper to, let's say, JACMP, but there is not a single JACMP citation, that also raises some red flags, right? So make sure that your manuscript is relevant for the journal you're submitting to. And often, if you're a student, talk to your supervisor, they might have some good ideas about where your journal should go to. So I would also say that something I don't think, Tim, you mentioned, but do watch out for predatory journals. You might be forced by your supervisor to submit to a journal that might be a little questionable, and it seems like to me, I don't think I have done it, at least I'm not aware of it, that I would submit to a preparatory journal. They tend to be open access and more of the, $3,000 price tag, and they don't necessarily have high quality peer review. And you can, often really easily check by the timelines that these journal impose on reviewers or on the process when, a paper gets accepted within 2 weeks from submission, right? That's a little questionable, and there are stories behind all these open access journals. But of course, so publishing open access is beneficial, as Tim was showing earlier today. So it does have some advantage for sure. All right, so I suppose this is another Slido poll. And in this case, you actually get to type in. So if you have published, and I know not everybody has published, so let's see, what journals have you published in? So in general, these journals would be Physics in Medicine and Biology, Medical Physics, JACMP. So I'll wait a little bit. It seems like not everybody has published, but if you know and are willing to type in, hopefully say some JACMP. Perfect. I was hoping, Tim, that you would get something. Oh, okay, magnetic resonance imaging. I did not mention that one. So we at least have 2. Excellent. NEMA, MedPhys, PMB, brachytherapy, and that's the one that I actually wanted to put in as a good journal for brachytherapy research. Okay, so clearly JCMP is working well, yeah. But I would argue that medical physics and medphys could be a little higher. GINS is also another one that is reasonably easily published in Journal of Radiotherapy in Practice. And if you guys are new to this, and even for me, take a screenshot of this, because you don't necessarily always know about all these journals. So it's nice to see what kind of, again, venues we can, Physica Medica, we can publish in. Frontiers in AI, excellent. I want to wait for one more, so if anybody can make up something. Anyway, now PMP is a big one. Okay, advances in radiation oncology. Perfect. Thank you very much, everybody. Nature, excellent. Nature, or Nature something else? Was it you, Tim? No. Anyway, so if somebody published Nature in Nature, that's fabulous. All right, thank you very much for this. And again, this is a good overview for journals that are relevant to this audience and to medical physics in general. Excellent. So as I mentioned, I was a deputy editor of medical physics, so I can tell you how the journal works. What happens with your article after you submit it? Because sometimes it's not necessarily very clear. Often it's not clear what happens, but also with this caveat that every journal works slightly or maybe sometimes completely differently. But for medical physics, for which John Boone is the editor-in-chief and Stan Benedict is the editor for therapy, you submit your manuscript, then it undergoes quality control. One of the steps in quality control is using AI to figure out, have you just copied somebody else's paper, or have you copied your own paper and didn't modify things that you should have modified? So it's possible that the manuscript will get back to you, and you're asked to fix some of the things that the quality control highlights. Then if the quality control is passed, it goes to the editor-in-chief, who selects who is the deputy editor who will be overseeing your paper. The deputy editor now selects associate editors. It's typically 2, might be more, depending on how the review process goes. And the associate editor is only 1. And then the associate editor selects referees who provide review, after some time. That can be anywhere from 1 day to 6 months, unfortunately. Then the reviews go back to the associate editor, who makes a recommendation to the deputy editor, who makes a decision that's eventually endorsed by the editor-in-chief, and then you hear back. So as you can imagine, there is a few people that are involved, maybe 6-7 people in total, that have to look at your article before you hear back. So typically, again, this on average, I think, takes about 2 months for perhaps an average journal. Again, it's going to be much faster for some of the predatory journals, can be much slower when the process doesn't go well, or when somebody doesn't do their job, which could be me as well. And then you work on your revisions, and the process goes basically the same way one more time or even 2 more times. So it's important to understand that this is a process that involves many people and therefore does take time. So don't email the journal after a week, like I haven't heard back. You're never going to hear back in a week, right? And sometimes people do that, unfortunately. So it's important to know. Okay, so how can paper writing be very enjoyable? You get to present your hard work, you get closer to getting your degree, you make your CV stronger for your next job, you make your supervisor happy. I'm a supervisor, I'm always very happy. But also you will be kind of done with that project, so that might be a relief. But it can also be very, very painful, and it's to a degree up to you to decide how you're going to approach it. Okay, so the next one, if you have written a paper, do you enjoy writing papers? Who does and who doesn't? So, or maybe you enjoy it somewhat. I suspect somewhat will be, hopefully. Oh no, I was very wrong. I expected somewhat would be the most common answer. Oh, very interesting. I guess we are physicists for a reason. Maybe writing essays has never been our forte. Very interesting. So I did expect that only a few people have, really enjoy writing papers. But it is also interesting. If you really hate writing papers, you see that you're not the only one. And if you enjoy it, then good for you, because it'll make your life much easier, especially when you're about to write your thesis, whether it be honors thesis or PhD thesis or master's thesis. Okay, so how should you approach writing a paper if you know you have enough information to actually do that? So there's a few strategies how to do that, and actually like one that's completely different from what I'll be describing right now. But what I usually do with my students, we look at figures and tables. Okay, this is the first thing you want to look at. You look at figure captions, and that actually figures and their captions should tell the entire story of your paper. You need to keep captions clear and concise. Then you can work on materials and method, because those are really easy. You just describe what you have done, right? It should be very straightforward. Then results and discussion. That's sometimes tricky because some journals want you to just separate results and discussion, and then it becomes tricky how much you say in the discussion about the results. But the results in that case should be very matter-of-factly stating what the results are. And in the discussion, you can talk about the implications of the results. Introduction is typically, from my experience at least, and from my students' experience, is the most difficult part, especially for the first paper when you're getting familiar with a new topic in a way. And do spend enough time on literature review, because it might pay off, because you might end up citing the reviewers' publications. That usually makes us quite happy when that happens. In conclusions and abstracts, you can work on these last. But I'm going to say it, some people prefer writing your conclusions first, basically to demonstrate what is the take-home message. Do you have a take-home message? If not, maybe you should not be publishing your research. So what are the writing tricks of the trade? You need to make sure that after people read your introduction section, they understand what you're trying to answer. What is the research question? Keep consistent order. If you say, if you mention energies of your X-ray beam, always mention them in the same order, in the methods, in the results. Repeat the key terms. Don't, in English, for me, in Czech literature, we would always be taught like, oh, use all these, different words, the synonyms for the same thing. Don't do that in scientific writing. It should be only one word for one thing. Keep consistent point of view. Don't say we did that, it has been done, somebody else has done, keep consistent. Use topic sentences with transition and key terms. So when you finish a paragraph, you should start a paragraph with the sort of same key terms. And put parallel ideas in parallel form. This might be thought of as nitpicking, but I put an example here. What's a non-parallel idea? The new protocol improves accuracy, it reduces errors, and it makes the process faster. That's non-parallel. And parallel would be the new protocol improves accuracy, reduces errors, and speeds up the process. You can see that the second sentence reads much better than the first one, much more consistent. So what do you do with tables? You keep them clear and concise if you need them. You need descriptive table, caption. You have to pay attention to formatting. Use the same number of decimal places for all numbers. It becomes really confusing if there's different decimal places in the same number of decimal places in the same column. And you don't need to give the reader values to 7 decimal places. That's never needed, right? Make sure that this is also reasonable. If you quote differences, state how they are calculated in the figure caption as well, or in the materials and methods. Figure caption is even better. And when I was researching for this talk, I found a really, really cool website. So if you want to look at this one, which is from the Canadian institution on table or data visualization, it's actually very, very nice. And one of the things that they're saying, they're comparing tables to cartons of eggs. So if your data are eggs, then the table is the egg crate, which keeps data ordered, separated, and easily accessible. But eggs aren't served out of egg crates. Perhaps data shouldn't be served out of a table either. So if you don't want to serve your data out of a table, what do? You prepare a figure, and very often figures are way better representations than tables. So I'd say figures or picture is worth 1,000 words. I did say on Twitter that I wasn't gonna present in my Flash costume, but you can see that's me presenting at FRPT in Toronto last year. And you can see that I am crazy. So it tells you a lot about me just looking at this picture. But if the picture or figure is not great, then probably it's not worth 1,000 words. So this is, I don't know, I don't have the citation for this figure, but this is indeed a figure from a scientific paper. What you see is the figure. Let's look at the caption. Doesn't help very much either. It tells you what the axis should be, what's plotted, what's in A and B, and it's crazy, right? This figure is absolutely not necessary in this paper. Anyway, so let's go through how figures could be presented. And I'm really sorry it's going to take maybe not too long time, but I'll keep going for a little longer. So this is a figure that this will be figures that will be based on this data set. Of course, I had to pick a data set from John Boone's publication because he's the editor-in-chief of medical physics. But I think this was actually published in PMB, so maybe there's some conflict in his earlier career. Okay, so this is a figure that you can present. It's again based on the table that I have just shown, but of course this would be horrible if you did that. This is a much better figure for a number of reasons. One of them being there's axis labels. Yeah, those are important. Sometimes they're missing, as we saw in the previous example. There's a legend, which is nice. There's appropriate font size, maybe too large for this case. The lines are nicely visible. They're made thicker. There's grid lines. So makes it better. So do not cover the data with the legend, right? It's not good. You also still see it in scientific publications. Not great. You need to pay attention to legend order. I did have a poll, but we don't have very much time for this. So I was going to ask, which one do you like better? Unfortunately, we ran a free Slido poll, so we would have to do it on Zoom. So let's not go through that. But the take-home message should have been that the legend order on the left-hand side is better because it goes from the blue curve to the red curve, and that's exactly how the curves are ordered in the plot itself. So those are little things, but they help people visualize things and read plots a little better. If you use subfigures, it's a little better, and sometimes I struggle with some of my students to convince them that they should use ABCD rather than top, middle, bottom, center, blah, blah. So A and B, much better. Even better if you can put labels into A and B. Again, it's much easier for the readers to read what or to understand what you're actually showing. It'd be nice to also show the same axis spans on the y-axis and x-axis so that people can immediately compare what they are looking at. And of course, please provide figures in high resolution. If you're trying to look at somebody's data and read off what the values are because the table is not available and you get data that looks like on the left-hand side, it actually makes it much more difficult to interpret. Okay. So please, everybody use a citation manager when you're writing a paper. It makes your life much easier. If you don't use one, you will probably regret your life and hate yourself for a very long time. There's a number of options that you can use, BibTeX and LaTeX, of course, and Note Mendeley's under our papers. There's actually a nice website at the University of Toronto that has a nice overview of the different tools that are available for citation managers and what are their advantages and disadvantages. Okay, so what are the common mistakes that I am maybe sensitive to in manuscript when I review? There's not enough detail given, so the reader really should be able to replicate your work with the caveat that often there is a very strict word limit, And in that case, not everything can fit in, but sometimes you have the possibility to publish supplementary material. Sometimes there's too much detail given. Some information is actually not relevant to what you're trying to do or what you're showing, so maybe you don't need to put it in. And also not being consistent. So when you're using the tense, the verb tense should be the same. Don't switch, future, past, present. Very often you can get away with just past tense. So try it and see what happens. Terminology should be consistent, order of presentation, figures should be very, very polished. Make sure that you proofread your manuscript. So after you have finished it or you think you have finished it, take a break from it, do something else for a couple of days, get back to it and read it again as if this was a new manuscript. Look for typos and text consistency. Always define abbreviations for the first time and then use them throughout the manuscript. Perhaps repeat the full definition in the conclusion section. I think that's quite nice. Do not make up new words. One of my students used to say be Monte Carlo things. No, that's not a verb. Send it to authors and give them a timeline. If I get a manuscript from somebody and they said, could you please review it? And don't tell me when, it's not going to happen. If I know there is a deadline, I work by deadlines. Most people work by deadlines. I'm going to do a better job at that. So I think those are almost my last slide, sorry. Receive a positive or positive in quotes reviews and revisions are requested. Okay, that's great. Congratulations. That's really good news. Respond thoroughly on a point-by-point basis. Modify the manuscript accordingly. We are asking you as the reviewers to do things so that they are included in the manuscript, not that you tell me as the reviewer. Almost always you want to modify a manuscript based on a comment. And you want to copy all requested modifications into the response letter, because the last thing I want to do is to go back again to the manuscript. I want to be responding. I'm going to just be reading as the response letter. And absolutely do not despair if manuscripts gets rejected. You do revise, don't leave it the same way, but resubmit somewhere else, right? That happens very often. There's on my first slide, it has happened to me many times, so do not despair. The review process is not necessarily fair, but do always look to improve your writing, because that's the reason why it got rejected. Could be that somebody hates your supervisor, if it's not a double-blind process, but it could be personal, but there's always some stuff that you can improve, even after it gets published, unfortunately. Okay, so good luck with writing your papers. Definitely reward yourself after you submit your paper, even more so when it gets accepted, of course, but even submission is a huge milestone that should be celebrated. With this, I would like to thank all my institutions that I have been trained at and work at. Of course, my wonderful group. Jade is over there as well. And thank you for your attention and sorry for taking so much time.
Okay, thank you again, Magdalena. We're going to move right on to our last speaker of the day, so we can get going, who is Dr. Hallie Morrison. She's a clinical medical physicist at the Tom Baker Cancer Center in Calgary, where she also completed her residency. Her work focuses on SRS and SBRT, treatment planning automation, and ocular brachytherapy. Over her career, she's authored many scientific papers with a precise attention to detail to ensure proper structure and formality, effectively conveying the importance and impact of her research. So, Hallie, you can take it away.
Okay, great, thanks. Yeah, so I certainly haven't published as much as the previous speakers here. So as a clinical medical physicist, I do a lot of writing. It's just less scientific nowadays. A lot of procedure writing, but the same principles and requirements for clear, concise, straightforward writing applies. So I'll share. I don't think there's too much overlap, so hopefully some useful things to learn there. And yeah, I'll jump right in. I can get my slide to advance here. There we go. Yeah, so just acknowledging the U of C and Foothills Medical Center and the Tom Baker Cancer Center are in Southern Alberta, which is location of Treaty 7, which includes Blackfoot Confederacy, Tsuut'ina First Nation, and Stoney Nakoda. And it's also home to Métis Nation of Alberta, District 5 and 6. And then I have no other conflicts to disclose. Okay, so the topics that I was asked to present on and focus on is how to get started on your manuscript. I think there's some good parallels and overlap with what Magdalena shared. Nothing conflicting, I don't think, but generating figures, super brief, just going to my kind of little tidbits of advice. Fighting writer's block, some advice there. editing tips and writing style. That's where I'll focus mostly on, and then just some resources at the end. So how to get started, at what point do you start writing your paper? So probably your research is done or very mostly done. Maybe you're still kind of wrapping up a few things. Again, your background reading should be done or mostly done. You should kind of, again, have that context in place. Figures and tables in progress. So again, same kind of advice as what Magdalena gave. Usually that's kind of a good starting point, really figuring out like what's the story you want to tell, what's the data you want to emphasize, what's the important data. So again, those are in progress. Some advice I'll give is to create an outline. I find for me, this was always super helpful. And you know, the structure of papers is strict in a sense, and also, you know, there is some creative liberties within that. So it's usually a really good place to start because it always is roughly the same. You know, you have your intro, methods, results, discussion, conclusion. There is some liberties within, you know, exactly how do you structure that? How are your subsections structured within each of those? But spending a lot of time here and really detailing out your outline really helps you get into the actual writing part. And if you have a very detailed outline, exactly mentioning, you know, I want to talk about this, I want to talk about this, and then I want to mention this. And then really all you're doing in the end when you actually start writing is just filling in those bullet points and creating them into paragraphs. And if you spend a lot more time here, work with your supervisor or your co-authors or whoever's more involved in the writing and organizing your paper, then, you know, that'll really help you connect your ideas, make sure the flow works, make sure things are like in the right order, or if you need to shuffle things around, and it'll help you when you actually get to the writing, not being confused and shoot, how do I connect from this idea to this idea and then onto this topic? So definitely recommend spending some time there. It will save time later, and then your supervisor and reviewers will have a lot less red pen in your editing, hopefully. So again, here's my suggestion. So this isn't necessarily in the order that you'd write them, but just suggestion for each one. So, you know, in Magdalena's poll, I see not many people liked writing, and she mentioned too, intro often is the hardest. I actually kind of love writing introductions, but maybe that's because I've got my little formula. So hopefully I'm going to share that, and maybe that'll help some of you. So my intros are always organized essentially the same way. First, starting out with broad context. What's the topic? What area of research are you, you know, are you doing work in? And then so you kind of move from your broad topic and your broad context of the work you're doing to what is the gap? Where's the gap in knowledge, and what's the problem that exists that you're essentially trying to fill? And then, you know, your last part of your introduction, now you can explain how does your research fill that gap? What are you improving? Why is what you're doing useful? And that's a really nice way to put your reader into the context of your work and jump into your methods section after that. And you've kind of laid the groundwork, laid that context, and then you can get into the methods. For your methods and results, so, you know, likely the easiest sections to start with, I would recommend starting with those as well. Again, just organize thoughtfully. And that's where, again, if you've done that really thorough outline, you should just really be able to turn those bullet points into paragraphs and into sentences and so forth. For your discussion, again, if it is distinct and separate from your results section, this is where you'll discuss your results, really walk the reader through what they mean and why they're significant. I do find it as a reviewer frustrating if the authors haven't really described like what does this mean, because it may not be my specific area of expertise. So I don't want to have to figure out why is this meaningful and what does this mean. This is your opportunity to explain to them exactly what it means, why it's useful, and walk them through it. Again, in your discussion, you can compare to other published works. How is it different? How does it add? Is there parallels? Have you validated in a different way, different data? Again, that can go in your discussion. Think back to your intro. What issue were you originally trying to address? Explain to your reader how you've done that and what, like, basically how you've solved that initial problem you pointed out in your introduction. This also kind of creates nice connections throughout your paper, and again, just improves the flow and for the reader to really feel comfortable and well situated within the work you've done. One of my pet peeves, again, you know, maybe there's some leeway for this. Your discussion really shouldn't have any data unless it's really justified that it's part of a discussion. And what I mean by data, it's not data from a different paper, data that probably should go in your results section. And then finally, your conclusion section. There's different styles and options for how to write your conclusion. Most scientific papers, the conclusion is very short. very to the point, 4 to 5 sentences, no discussion in there. It should really just highlight what's the take-home message. And it shouldn't be a page long. So again, just little tiny paragraph. I'd say that's most common, not always the case, but that's a pretty well accepted style for the conclusion. Okay, so just jumping into, and just briefly here, Magdalena gave some great advice here. I don't have too much to add. I think all of these points complement her as well. Resolution, again, as a reviewer, it's very frustrating, and you can't always control how those, like usually the final paper, they're really nice, high quality figures, and journals often indicate, you know, when you submit them, you can submit the high res ones later, but if you submit really low res ones initially, what comes out for the reviewers sometimes is just like exactly like that screenshot she gave. It's super fuzzy. And I've had ones where that's one of my comments. I'm like, I can't see anything. I can't even review this paper. Like, ask the authors to resubmit. I have done that once. So don't neglect the resolution. Text and font size, again, making sure your captions are clear, making sure all your labels are clear. It seems nitpicky, but it's so much easier to read a paper if all of that is really clear. And because the figures, like as I said before, figures are worth 1,000 words, and that's where you can convey so much information. But if your readers can't read it, then what's the point? Figure captions, generally, they shouldn't contain new info that isn't in the body of the article. A lot of time, figure captions, especially when you're reviewing a paper, so again, just to help your reviewers out, the figures get slotted at the end of the article. So when you're reviewing the paper, you initially only see the text. And then I often, I'll admit, sometimes just kind of really glance over those captions and I'll look at the figure as I'm reading it. But if there's new information contained in that caption, very easy to miss it. So your figure caption should be nice and succinct, to the point, explaining the data, and shouldn't really have new information that isn't also in the body of the text of your article. You know, Excel generated articles, really don't recommend. They're also very difficult to control resolution, control text and scaling and things like that. Highly, highly, highly recommend using code to generate your figures, whether that's with MATLAB, Python, R, etc. And then you can save that code, and if you need to make edits later, you just make that one little tweak, rerun your code, bam, you've got your figure. You can control the resolution with MATLAB and things like that. So it's a lot easier to do with them coded. Paint.net is not a program, sorry I put it in that line, but it's a free software. I use it a ton. It's super nice. It's kind of like a free version of like Adobe Illustrator or something like that, and you can add different layers, and it's really nice for making figures. So it's free. It's a nice little one. They do update a lot and ask for donations. I just ignore it and carry on. But so if you're looking for some other program to help edit your figures and add certain labels and things like that, that's a nice one. And again, your figures should be really easy to interpret and very meaningful. You know, I won't go over this much. It was well explained. But ask yourself, is the data better understood in a figure, a table, or are those really not adding a lot? And it's just nice to summarize that data within the text. Obviously, you don't want to be putting 12 strings of numbers within your text. That's when you really should move it out into a table or a figure. But just ask yourself, like, how can I best explain this data to the reader, and where's most appropriate? Okay, so next topic, so fighting writer's block. I mean, you can Google this. There's lots and lots of resources available on the internet for this. So these are just kind of my suggestions and things that I found helpful and advice I give our students here. So take note of the environment and time of day that's good or not good for you, and what kind of gets you into the writing mood. Personally, I found like ambient music I hate, but like headphones with loud music right in my ears I love. I don't like writing at home. I liked working in my office. So, take note of those areas and those types of things that get you into the writing mood versus like environments that just don't work for you. Maybe a coffee shop and ambient noise works great. Dead silence doesn't. Just take note and figure it out, and then, get in that environment when you're ready to write. Productivity can look very different on different days. Don't beat yourself up if one day today's not a writing day. That's fine. And if you still feel like you're frustrated and want to be productive, there's a lot of other things you can do. So if there's a day you're struggling to write, work on other things, work on your figures, organize your references, read background material, clean up or edit a previously written section, work on formatting. If you're having a bad writing day, trying to force it, probably what you'll write that day won't be very good. So, don't beat yourself up. Again, you can still be very productive without churning out pages and pages of writing that particular day. And again, some advice I give our students. So the flip side of that is if you are in the writing groove, just go with it. Even if you're supposed to meet some friends, maybe cancel on them and just keep writing. If you're in the groove, keep going. And just balance it out that way. One day maybe you won't write much and one day you'll write lots, and don't beat yourself up if on those days when you're not writing much. If you are feeling stuck, just jot ideas down in point form, similar to working on your outline. Just think about fleshing that out more. Oftentimes, if you can jot down enough ideas, eventually you kind of just get yourself into that mode, and you can just start turning those point forms into full sentences and paragraphs, and suddenly you didn't even realize now you're writing and you're in a good writing mood, even though you initially felt stuck. First drafts, they're not perfect. Don't worry about it. Get the ideas down. You can always come back and read it and re-edit it later on. And similarly, if you're feeling kind of stuck and you're not sure how to phrase a particular idea, read other papers, go back to the background materials that you had, and read those. And, you might get some ideas for how different authors phrased and organized different things and explained certain ideas that'll help you out. Okay, so now I'm just going to spend a couple slides on editing tips and writing style. This is one of my pet peeves. I think some of the students, I'm getting known for this. If I'm one of their like on a committee or an examiner for the thesis, like they're prepared for a lot of corrections on this. So don't underestimate style, grammar, and syntax. It greatly improves the ability of readers to understand your work and the quality of the writing of your work. Reread and edit your article at least twice before sending it to your supervisors or co-authors. Have a fellow student read it if you need help. And I'll just jump into all these tips. So, what I call tips of the trade, things to consider, and my pet peeves. So the first one is active versus passive phrasing. So active phrasing tends to be more engaging, although most articles tend to lean towards passive phrasing, but it often reads more boring and more just like it's not as engaging and not as interactive for the reader. Sometimes one is more correct than the other, so it's not to say passive voice is incorrect. So an example of active voice would be like the cat chased the mouse. Passive is the mouse was chased by the cat. So it can change the emphasis of the subject in your sentence. So again, there's a place for each one. Usually active voice comes across more natural when you're reading it. So just reread and voice it aloud and determine which sounds more natural and which one feels more correct, but something to be aware of. Another one to be aware of is the use of we, our, and I. This one, I have no super strong opinion either way. I think there's a place for it, but a lot of journals really dislike the use of we and our and I in scientific writing. The one kind of flip side of that is to avoid using we and our often creates these convoluted sentences where you're writing very passively in order to avoid it. So again, just reread your sentences. And if you're bending over backwards to create this weird sentence to avoid the use of we, maybe it's okay to include that. And I will say in an article, I think it's fine to use we and our if it feels, if it flows better and if it's better phrased that way. A thesis, I'd say not so much because it really is your work at that point. So just be careful with the use there. Again, that's my opinion, not, there'll be some variations. So hear about that. One thing to keep in mind too, if you are using we in an article, just make sure that the way the sentence is structured focuses on the work and not on we as the subject. So an important one, this one is probably one of my biggest pet peeves, is precision in language choice. Using the correct word is a lot more important than reducing the number of repeated words, or trying to using a synonym to make it sound better. Often that synonym will just be incorrect. So it's more important for you as the writer to be using a dictionary rather than a thesaurus. And so often a synonym will just be incorrect or imprecise in that context that you're trying to use it. So just focus on using the correct word. So another thing, scientific writing, generally very succinct and very direct. Scientific articles are not the next great American novel. Fluff and artistic phrasing should not be used. So again, it's going to be very differently phrased than how you read magazine articles or novels or things like that. Scientific papers are meant to be informative. So, ask yourself, does this sentence inform my reader? Does it give useful context to provide information needed to convey and explain the things I did? If yes, great. If no, you can probably scrap it or rephrase it in some way. Choose your verb tenses intentionally. Again, it's hard and it doesn't read well if you're flip-flopping between verb tenses within the same sentence. It's grammatically incorrect. Usually past tense is fine. Again, it just kind of depends how you want to phrase like that, the work you did, and whether you're saying, this was measured or this is like this now. So really just think through it. You should not be flipping between verb tenses within one sentence. And generally paragraphs should all be phrased within the same verb tense unless you're speaking about, again, data being measured prior or following something else within that paragraph. So again, just something to be mindful of and think through it when you're reviewing your article. Avoid filler words, zero phrases, and redundancies. Again, this just makes your sentences a bit more convoluted than they need to be. It's just extra fluff words that detract from the information being conveyed. So, examples of redundancies are common English phrases where two adjacent words essentially mean the same thing. So saying at the present time versus just saying at present. Currently underway, like those both mean the same thing. So just saying currently, this is the status, or this is underway, something like that. Zeros are phrases like, it's interesting to note, as a matter of fact, it should be pointed out. Like these don't really add extra information and they just kind of detract from what you're trying to say. Again, avoid long, convoluted run-on sentences. The longer and more complex your sentences are, the more likely your reader at the end of reading a paragraph is going to go, eh? And then if I am reviewing an article and if I have to read a paragraph twice or three times and I still don't quite know what they're trying to say, it makes me as a reviewer very frustrated and it puts you in a bit of an annoyed mood, which is not where you want to place your reviewers when they're reviewing your article. So really, again, scientific writing, just very to the point, very straightforward. Again, not complex, convoluted sentences. Parallel construction in sections can really help your reviewer as well. So an example of that, if you've got subheadings within your methods, so then section 2A in your methods is parallel to section 3A in your results. Section 2B methods, now you've got section 3B in your results, explaining the results of that particular section. Again, not always possible, but if you can do it, it's really a nice format and helps guide your readers through the work you did. Be consistent in the use of labels, acronyms, abbreviations. So, if an acronym is super well known in the field, that's fine, like OAR, PTV, RO, like these kind of words, like we all know what these mean, like that's fine. They should still be defined and the first time you use them, but that's usually pretty well accepted. But in order to use an acronym in your paper, you should have used it at least 2 to 3 times within your paper. If it's an acronym that you've created within your paper and therefore unfamiliar to the reader, ensure it's actually beneficial to use it. If you introduce too many, your reader will start to get confused about, wait, what was this one? What's this again? What's this? And they'll have to jump back to the original definition. Keep in mind too, where you defined it and then when you next use it. If you first defined it in the very beginning of your method section and you don't use it again until your discussion section, probably your reader is going to forget what that was. So in that instance, even if you used it 3 times early on and then you don't use it till later, probably best to define it again. And then again, just consider transitions between ideas and paragraphs. Think about the flow from one idea to the next. The better organized your sentences are within a paragraph and how your paragraphs are organized within a section, the easier it's going to be for your reader to move from one idea to the next and understand what you did. And it'll just make it a lot easier for you to convey all your ideas and for them to connect adjacent ideas within sections. And that'll all just really help your reader absorb all the information you're trying to convey. So very last slide here is just some resources. So again, every university has graduate student writing resources available, whether they be online or in-person help. I Googled, Canadian university writing graduate student resource, and like every single university had a website that come up. So all of them have this available to you. It's usually free. You just have to schedule time with them. They obviously won't understand the science you're doing, but they understand English and can help you with your grammar and syntax and the ideas and how to convey those so that other people can understand what you're doing. So they can help with more of the English and the writing and that aspect, whereas obviously your co-authors will vet the science and vet the actual accuracy of what you're giving. This was a book that my supervisor, I think it was like the second week I was with them, he was like, this is not personal. I give this to every student, and he handed me this book. It's actually really good. I like a lot of the notes I gave came from there. I don't 100%, you know, agree with everything in the book. Probably like 95%, 90% is really good. It's not too long, and I have the 3rd edition. There is a 4th edition out now. So again, there's lots of good resources out there. This is just one particular one that I like. Again, there's lots of others. And then lastly, like, you know, read non-scientific things. Scientists are not in general trained writers. Like the last English course I had to take was in high school. So it's been a long time for most of us since we had formal English writing and literature training. Again, you know, to note, like novels are not written how scientific articles should be written. They're very, very different. But you can still learn about like expand your vocabulary, learn about proper syntax, like get familiar with grammar by reading other papers, whether it's like magazine articles, news articles, novels. You will just slowly absorb how to properly write and structure your sentences, and it'll just come out naturally in your own writing. Again, not everybody loves reading, but I find that really helpful. So, and that's all I have. So hopefully we still have some time for the discussion. And again, thanks very much for the invitation to speak, and hopefully there was some useful tidbits in there for all of you. I'm going to stop sharing.
Thank you so much for your great presentation. I really appreciated that. I do recognize that technically we've pushed the time limit a little with our presentations. However, we'd still like to give the option for anyone in the audience. If there's questions you'd like to ask, this is a great opportunity to do so. These are speakers who are extremely knowledgeable about the subject. So if you have questions, you can either raise your hand or drop it in the chat. If there's no questions, I'll give a few minutes, but I suppose I can ask a question to see. I was wondering if you guys had any advice for often if there's priorities for referee comments, particularly if you get contradictory responses from referees. Do you guys have any advice for how to approach that?
I think navigate carefully. I think you probably identify with one of the comments rather than the other one, and it does happen, you know, reasonably often. So if you have, you know, preference to agree with referee 1, which disagrees with referee 2, then you can probably pretty easily tell referee 2 that, you know, because referee 1 asked for thing A and you're asking for a thing B, you more associate with thing A, and then, you know, because they are in conflict, you're responding that way. But you of course should be nice about it, acknowledge that there is disagreement between the referees, but do whatever you feel like it's most reasonable. But it has to be, again, acknowledged and treated appropriately and carefully. That's my advice.
Yeah, I agree. And, you know, a good associate editor would hopefully help you with this, but that's not always the case, and sometimes not even often the case. So I think Magdalena gave some good advice, and always make your comments super respectful and super appreciative. Reviewers really like that, even if they're completely wrong, still be appreciative.
Then you respectfully disagree when they are completely wrong.
Thank you for that great answer. I really appreciated that. Oh yeah, there's a question in the audience from Morgan.
Hey, thanks everyone for your really nice presentations. My question had to do with selecting a journal. So Magdalena, you touched a bit on sort of the breadth of journals that we have access to in medical physics, but especially for projects that fall maybe a little bit outside, how do you decide which topic or which journal is best suited for your work?
I think, you know, I already mentioned that if you're, you know, you put your paper together, it's kind of tricky because you often want to decide on the paper before you start writing, because you might have 12,000 word limit, or you might have 6,000 word limit, which will result in a very different paper. But look at the publications that you're citing and the journals they have been published in. I think that is a really good rule of thumb, and that's probably, again, the best home for your work. There's new journals as well that you can look into. But I think, again, looking at your own references in your paper should give you a good idea about where your paper should be submitted to. But I already said that, so if anybody else has any other suggestions, you should speak up.
Yeah,
Yeah,
Andrew.
I think I would agree with that as well. Like usually once you kind of get familiar with those journals and see where the references you're reading, where they're coming from, you do get a sense for, and like Tim explained it very well, between GACMP and MedPhys, like one is more basic science, one's more clinical. And there is a little bit of that distinction for a lot of those sort of parallel similar ones. Like I think one that wasn't mentioned earlier, like I think it's a bit of a daughter paper, I'll call it, or journal from Red Journal is Practical Radiation Oncology. So again, that was like a little more clinical focus. So, and you can always try for the big one. And then if that one's not accepted, okay, go on to this one. Like there's nothing wrong with that too. So yeah, I think with the expertise from your supervisors and just what you've read and what they've published, and again, where they're referenced, should give you at least like an initial starting point of where to go.
And I think for you, Morgan, you probably are working more on like a interdisciplinary research, so it becomes a little more challenging. MedPhys or PMB might not be the best homes, but you can always submit and see what either the editor or the associate editor has to say. And sometimes people have good suggestions about where your paper could go to.
Oh yeah, actually, that's a good point. I'll add. We had one paper, and it was done in collaboration with a biology, like DNA damage research group. And I think initially it was like one of the sub-nature groups. And that the reviewers there were like, I don't think this is quite right for us, but they actually pushed it on to an associate journal. And so then we didn't even actually have to resubmit it. And so sometimes too, if you don't quite pick the right one initially, the editors can give you good advice for where to push that.
And one thing that I notice increasingly is that, if you've got some really strong work, I see people moving a little outside of our traditional field of journals. For example, Nature Scientific Reports has an impact factor of 6 or something. And I can think of several of the strong academic groups in the US that are publishing there more often, or PLOS1 or some of those. So I do think that trend is increasing a little bit, but of course those have to be pretty strong work.
I want to correct you, Tim. I always thought that Scientific Reports has a good, very high impact factor. It's actually 3.8 only.
Yeah, it used to be higher. You're right.
Yeah.
So it's still higher than MedPhys.
Barely.
I think, one of the other reasons to do that though is just exposure. Because those journals have a much larger reader base.
And I would say, Morgan, I would think that for your work, this Scientific Reports might be a good journal.
Thank you.
We have time for one more question, if that's okay for the speakers. Andrew, you've raised your hand. You can go ahead.
Yeah, sure. Thanks a lot to the speakers. Really interesting stuff today. This question might be a bit controversial. I'm not really sure, or it might be like sort of a delicate scenario, but suppose you got a reviewer's report, a referee's report that asks you to cite their papers. Specifically, like, I will recommend this paper, but you should cite these papers of mine. And like, if you don't really think that relevant or necessary, how do you sort of handle that in the response?
That's not controversial at all. A reviewer should never, ever do that. And a good AE would correct that reviewer.
Yeah, so I mean, I agree with that. Unfortunately, it happens too often, right? And I have been the person to tell people, don't do that because it's not relevant. And sometimes I don't hear back from them, but that's okay. So Andrew, to be fair, you don't know, right? If it's cite my papers, and to be fair, sometimes, and I've been told by people that they recommend somebody else's papers. So it's not necessarily their group, because most our journals at least are in random model in which the reviewers are anonymous, right? You don't know who they are. That's not always the case either. So I would say, maybe just give people benefit of the doubt, but I would say, should it be included in your literature review? Yes, perhaps some of it's added. If not, because it's discussing something different, don't do it, right? And I struggled with that just recently with Nathan, who might still be on the call. We just, had a discussion. I'm like, yeah, but it does discuss a similar topic what you are investigating, so it's not outrageous to add it. However, sometimes people ask for their work or some work to be added that's completely irrelevant, right? So if you can justify it one way or another, absolutely do it. Don't be afraid. But again, understand that you don't know if this is actually the author's. Sometimes it feels like it's very obvious that this is the referee is the author, but it's not necessarily the case.
But again, the associate editor knows, and a good associate editor is going to hopefully address that upstream.
So
If it's relevant, fine, in the right context, perhaps, but it's really frowned upon if a reviewer says, cite these 3 papers, and they're all papers from the reviewer.
Yeah, for sure. And I sometimes as the author, I do email the editor-in-chief and say, look, this is what happened. I am suspicious, and you should, if that's the case, you should talk to them. And as an associate editor, what I say, I tell the authors only include references that are relevant to your work. So it's in a subtle way to say, if you don't include them, it's perfectly fine. But I also don't tell sometimes I do tell the referees not to do that, but it's tricky. But if there's no way that work is related to yours, absolutely disregard it for sure.
Yeah, I think in your response letter, just politely decline and say, thank you for the suggestion, however, not deemed relevant, and just, but yeah, I would assume like the associate, if they were really seeing that, because they review the reference letters before they go out to the authors. But and I've personally, as a reviewer, recommended a different paper, not mine. So like Magdalena said, don't necessarily assume it's they're trying to self-reference or provide their own references, but because there sometimes are just like, oh, you missed this really great paper that like totally supports your point, here you go, like I'm trying to help you out kind of thing. So but yeah, if you disagree, just politely, like with any comment made by a referee, aside from those, just any comment they make, if it's really not applicable or they're not quite they're missing the point or something, just explain and politely disagree.
Great, thank you.
Yeah, thank you. So that brings us to the end of our session. We want to give a huge thank you to all the speakers for the hard work you put into your presentations and for taking the time out of your day. So huge thank you for that today. We also want to take this moment to let you guys know that coming up on July 11th, there will be a joint networking session hosted in collaboration with the Student Council, as well as the American Medical Physics Association Student Council. And this will be a good opportunity for you to meet awesome speakers like the kind we had today, and to get a really good opportunity to really chat with them, ask questions in a casual environment. So if that's something you're interested in, you can check out the QR code there, and it's also on all of our socials. So thank you everyone for coming out today, and huge thank you to our speakers.
Thanks so much.
Thank you. Bye.
Thank you.